Yes. Okay. Now where are we? We have started the trees, and let me take two trees first. What happened with the system? Okay. We can see this in trees. This is the syllabus for us. Basic terminology and representation of graphs using adjacency matrix. This was graph, no, this is tree here. Okay. Basic terminology, binary tree and its representation, binary tree traversal methods, binary search tree, evil tree, B tree, B plus tree, heap and its operations. So we also have heap here. Where? Here. Heap sort. Let me complete BST till here, binary tree first. Then we'll come to what is heap and its operations and heap sort. Okay. Uh, let me ask once again someone so that I can continue without interruptions. Okay. Pranav, is screen visible? I am audible?
Sir.
Okay. Okay, fine. So basic terminology in trees are what? Like what is a tree and all. Let me again just we have IC2 component 2. IC2 component 1 I have taken. Okay. And those result is also put on the Moodle 2-3 days back. Okay. And yesterday I have put in the WhatsApp group, I think, who have missed IC1 component 1, IC1 component 2 and IC2 component 1. Okay. You all have to later call me personally so that we can schedule something and we can take your IC components. Now what is left is IC2 component 2. So I will take a test again, like IC1 component 2. We had a test of 4 questions, 5 marks, where you have to solve the problem and write the answers, isn't it? Likewise here also. No, that was earlier before MSc. What we have done? Maybe there infix, postfix, those conversions were there. So the test which I am taking, ISC2 component 2, will be after orals. Okay, maybe we will schedule it on 21st or 20th or 21st. Okay, during PBL we will take ISC test and ISC2 component 2 test and we will start with PBL. Okay, so now today who is having DS lab orals? Which batch? Which batch is having orals? S1, S2, isn't it? S1, S2, you have your internal orals today. So what is the process? You have to pick up. I have shared a number of experiments which will be there for your internal test. Have you gone through it yesterday? I have put in the WhatsApp as well as I think where is my WhatsApp? Let me see. Okay, I have put yesterday all that information. Okay, so you all have to be likewise like yesterday. DCN test was there, no, for you internal. Okay, 916. Who is this? Try again. Okay. I have shared what information I shared. Okay, experiment list is also was present on the WhatsApp group. Okay, so how many experiments are there? Yes, how many experiments in the list? 31. Roll number 31. Rajvardhan, are you there? 31. 31 is not there. 31. Okay. 38. Rishikesh Sali. Rishikesh?
Yes, sir.
How many experiments are there for ISC DSL lab today?
Sir, DSL lab.
DSL lab, DS internal. Which experiments you have to prepare?
Yeah. Sir,
How
you
many?
have shared the list, no?
I shared it on the WhatsApp group. Maybe I have put it. I have put it on the this thing. Where on the Moodle? I don't know, but WhatsApp group it is there.
Yes, sir, around 10, 8 to 10 are there.
Only 8 to 10. You have not seen the list?
I need to see around, yeah, sir. Sir, 16 are there. 16 are there.
मग तू वाचलास की नाही रे?
सर वाचले होते फक्त हां सर 16 आहे 16 आहे.
Remember, you all have to switch on your camera during your experiment writing. Yesterday you have done the same thing with Recin also. So today also you will do the same thing. You all have to switch on the camera during your internal orals. Which batch is having internal today? S1, S2, isn't it? S1, S2. Today you have to give DSL oral today, tomorrow, and on 20th and 21st, PBL presentation in a group you have to do. Okay, that list also I will share. The group once again you have to confirm the groups, and you have to give the PBL code representation as well as PPTs. And I have shared on the Moodle the link for PBL code uploading as well as your PPT uploading and report uploading. And I have shared you the sample report also. Okay, if you want to make any changes in the report, that is possible. That is permissible. Okay, you can make changes as you want in the report, and you have to upload the soft copy of your code, soft copy of your presentations, and soft copy of your report. So one person in a group can upload all these 3 documents, and I will schedule the timing on 20th and 21st group wise. So in a group will join WebEx and they will give the presentation. Okay. Now today we will have at 11:30 sharp. We will start with our DSL lab. So randomly you will get a program. Okay, one of the program from those 16 programs, and you have to prepare. You have to write the program for that. Write the program, take a snap and upload. Okay, you can directly take the snap and upload on the Moodle. Okay, I will share the Moodle. I will make a Moodle link where you all have to upload your files. Any questions? Any questions? How many of you are not having any laptop and all? Who is not having a laptop? Does everyone has a computer or laptop? Okay. Anish Pawar, no laptop. Shreya Katwade, Preeti, laptop in the sense computer laptop. You don't have anything. Okay. Then what you will do? You will write a program in the. So where are you writing the program? Where you will write the program? On mobile. Fine. So write the program in the mobile. Okay. And you have to take a snap of it, or write a program on the paper. It is okay. Write a program in the paper neatly. Take a snap of it and upload. And you have to upload it on the Moodle link. Is that okay? Okay. Now we'll start with the tree. I will just brush up the revise the basic terminologies, and we'll start with binary tree and its representation, and a program to create a tree. Program to create a tree in C. That will create a tree, and maybe in the next lecture, tomorrow or after tomorrow, what we'll do? We'll take binary tree traversal methods like in order, pre-order, and post-order. Can someone answer? Is most of the tree concepts are covered in DMS? Ashwit?
Yes, sir.
Trees over in DMS, trees over?
Yes, sir. Over it is.
Okay. So, shall I? I think I have taken all the basic terminologies last week, isn't it?
Yes, sir.
Okay. So what I will do, I will lightly start with the binary tree and its representation. Okay. Binary tree and its representation. Then I will take a program in C where how to create a tree. And maybe in the next lecture, one more lecture, we'll do binary tree traversal methods. Binary tree traversal methods and binary search tree. Okay. Let me open this. Okay. So what is tree? Now tree is a non. We have seen in the last lecture also that tree is what? Tree is a non-linear data structure. Okay, like we have linear data structures like arrays, linear. So tree is a non-linear data structure. Tree is non-linear data structure. Okay, what's happening to this? Tree is non-linear data structure. Okay. So what is linear, non-linear? Linear, we have arrays, stack, queues, linked list. Okay. Whereas in non-linear we have graph and trees. Graph and trees. Okay. Now, why arrays are linear? Because what we do we store data one by one. Okay, and all are at same level. Okay, same level one by one. Whereas in graph and all, they are like we have different levels here. Okay, they are at different levels. So hierarchical relation can be represented in graph and trees. So that was a linear and non-linear. Okay. Now, if you see the basic terms, we have seen all the basic terms. Like suppose I have a tree A, B, C, D, E, F, G. Okay. Now, like in natural tree, okay, in general trees are what? Trees we can see trees outside, okay, on the ground. So what are they? The trees start with from the ground, isn't it? Root is at the ground, then we have branches and the leaves, okay. But whereas in computer terms, now if you turn that upside down, the natural original tree in computer terms, it becomes like this is the root. Always this is the root of the tree. Now, first let me explain what is tree. Tree is a non-linear data structure. Tree is a non-linear data structure consists of nodes and edges. What are nodes? Nodes are its elements. Okay. Normally we call elements. So tree is a group of nodes and edges. We don't call elements. but they are elements. So why node? In array we call elements and all. What is node? In linked list and in tree we call nodes, because nodes is what? It will have information. It will have information. Also, it will have link, plus it will have link to next node. Next node. So here A is a node which will have information like A and link to next node which is B and C. And always remember, tree traversal is only one way. Okay, like what? From top to bottom, from A to B. We don't normally mention these arrows, but by default the tree traversal is from top to bottom. Okay. Okay, top to bottom means what? The flow is from top to bottom. But in traversal, we can, if you see which pre-order, post-order, first we traverse to D, then E and all. But normally the relation is from what? Relation to A to B and all. And what are edges? The links which connect. The links which connect are called, the links are called as what? Edges. Edges are the links between nodes. Plus we have some more terms like this is the root of tree. It is it has two outgoing arrows, you can see B and C. So we have a relation called parent node, child node, okay, then ancestor, descendant, and all many things. So suppose if you see a parent node. So first thing, what is root node? Root node is the first node having no parent, the topmost or first in hierarchy. So this is root node. So root node is the first node in tree, first node in a tree with no parent. Tree with no parent. Then what is the parent node? Parent node the immediate predecessor of any node is known as its parent node. So suppose take example G. Its immediate predecessor is who? C. So C is parent of G and F. So parent node is what? Immediate predecessor of a node. Predecessor of a node. Okay. Then who is child node? Child node or child nodes are the successor node of any node. Suppose I have a B, node B. So who are its children? Child. So D and E are its children. Okay. So child node is what? Immediate successor of a node. Immediate successor of a node are its children. Okay. Then who are siblings? Siblings are what? If nodes are having same parent, okay, like here F and G are having same parent C, then they are siblings. Now we can see that we have at last some nodes D, E, F, G. These are what? Non-leaf nodes. They are at the end. Sorry, it's not non-leaf, it's they are leaf nodes. So we have first we'll take leaf nodes, non-leaf node, then we'll come to non-leaf. Non-leaf nodes are what? A, B, C, these are non-leaf nodes. A, B, C nodes are non-leaf nodes because they have childrens. Okay, they are not at the end. These are also called as non-leaf nodes are also called as internal nodes. Okay, whereas we have leaf nodes D, E, F, G. D, E, F, and G. These are Leaf nodes also called as external nodes and sometimes external nodes, sometimes terminal nodes. Terminal nodes. Plus what you have seen earlier, we have seen path. What is path? Suppose A2, I want to go to A to G. So how I can go? I can go by A to C and C to G. So the path is A to C, AC, H, and then CG. So this is the path. So path is the consecutive edges from a source node to the source node to the destination node. That is path. A sequence of consecutive edges from source node to the destination node. That is called path. Then some more terms like who are ancestor and descendant. Okay. Any predecessor node on the path from now here it's not just a parent node, it's an ancestor node. So take this example. Suppose ancestor of D. D is ancestor. Okay. So any predecessor node on the path from root node to that node. So this is the root node. So any predecessor node. So this is the path. This is the path. So any predecessor node of a path from root to this particular node is called. So root is A and destination is D. So on this path, what we have? We have A, B, then D. So A and B both are ancestor of D. Ancestor of D. Now take, suppose I have one more, node H. Then who are its ancestor? Ancestor is E, B, and A. This is the path. So A, B, E are ancestor of node H. Then what about descendant node? For a given, suppose B, if you take a node B, now from my path from B to its leaf node, all the nodes, successor nodes are its descendants. So from B to we have E and H. So these are descendants of B. Also here we have one more edge, B to D. So D is also a descendant of B. We have seen all this. We have seen just clearing your things because we are not going to come back here again. Now, what is the degree of a node? The number of children of a node is called its degree. What about A? A is having a degree of A. Degree of A is 2. Now, what is the degree of node is? We can have tree like this: A, B, C, D. So what is the degree of A here? The degree of this particular tree, degree of A is 3. Okay. And suppose I have one more here, F and G. So degree of B is 2. Now what is the degree of a tree? Degree of a tree is the maximum degree of having any node. Any node, suppose in this particular tree, a node is having a more degree, that is the degree of a tree. Suppose D is having 4 nodes. D is having the 4 nodes, then the degree of tree is also the maximum one, which is degree of D, which is 4. Okay, so this is enough, but some more terms: height, depth, and level. So A is level at A is level 0, B is level 1, and this is level 2. Okay, so what is level? Level, the distance from root node to a given node is called level. So root to root is 0, so that's why level is 0 here. So okay, I will take all these things. Okay, let me draw some more G, say HI. So level is, so what is level? Level of a node is the distance from root node to a given node. So level of root to root is 0, level is 1 here, and level here level is 2, and here level is 3. Now what is height? Height height of a node, number of edges in the longest path from that node to a leaf node. Okay, number of edges in the longest path from that node to a leaf node. So if you see the A, what is the longest path here? Longest path can be this here. So 1 2 3. So the height of a root is 3. Height of a root is 3. What about height of C? 1 2. It is 2 of C. Then what is depth? So what is the height of a tree? Height of a tree is number of edges in the longest path. Suppose we have from A, we have this path to the leaf node, which is only 2. What is the longest here? A to C, C to G, G to I, which is 1, 2, 3, which is the longest, that is the longest path. Again, A to C, C to G, G to H. This is the again longest path, which is 3. So 3 is the longest path. 3 is the height of root node. One more term, what is depth then? Depth, length of the path from root node to that node. So if you see the depth here, depth of root node is what? It is 0. So what is depth? Depth is length of the path from root node to that node. So root to root, what is the path here? 0. Then what about here? For BC, the depth is 1, because the distance from root node to these nodes, this node is both B and C is 1. Depth of these nodes D, E, F, G. D, E, F, G is how much? It is 2. And depth of the nodes H, I is 3. So depth is what? Depth is length of the path from root node to that node. So you can see that level and depth are both are same. Okay. So this is enough. We have seen all these things earlier also. Now basically in computers we use binary tree. Okay. Now why binary tree? The applications in computers are basically in binary in mostly, so that's why I use binary tree. Okay. Now what is the then binary tree? So a binary tree, binary means 2, isn't it? So a binary tree can have maximum 2 childrens, maximum 2 child nodes. So in a given tree, if any node is not having more than 2 children, that means it's a binary tree. Suppose take this 1, so 2 children. This is a binary tree. Now single node, no children. This is also binary tree. Single node, 1 child. This is also a binary tree. Okay, binary tree with 2 children, 0 child, 1 child. Okay, suppose if I draw this one, so this is not a binary tree. Okay, understood what is binary tree? A tree having nodes not more than, any node having more than 2 children is called binary tree. So if it is having more than 2 children, so this is not a binary tree, not a binary tree. Now how we are going to represent binary tree? Types of binary trees, we have full types of binary trees, binary tree types. First one, okay, full, we call it full, proper, strict, full tree, full binary tree. or we call it sometimes strictly binary tree, or we also call it as a proper binary tree. Okay, proper binary tree. So what is mean by this? If in a tree where each node contains 0 or 2 nodes, then that is full or strict, or we call it proper binary tree. Take this example 1. So either it, what is the condition here? It should have 0 or 2 children, two children, that is child nodes. So it cannot have 1, it can have either 0 or 2. Suppose this is a binary tree. Okay, what about this? This is a binary tree. What about this? So this is not a binary tree because it is having 1 child. So this is not a full or strict binary tree. Suppose you will draw one here. Is this a binary tree? No, because we don't have anything here. So to make this, either you should remove this. Okay. So either you can remove this one. So this can be again a binary tree. Why? Because it is having A is having how many children? A is having 2 children. Here A means this level. Here it is 2 children, 0 children, 0 children, 0 children. So this is a binary tree where if you take here, okay, this will become 1. So this is not a binary tree. This is not a full or strictly binary tree. To make this happen, you have to make this both the nodes. Then this will be 2, and it's a full binary tree, strictly binary tree, or proper binary tree. The second type of binary trees, the second type of binary tree is complete binary tree. Complete binary tree. First one was what? First one was full binary tree, which is also called as proper binary tree or strict binary tree. Then we have complete binary tree, second one. So in this, all the levels are completely filled except possibly the last level, and the last level has nodes as left as it's possible. What is the condition? All the levels are completely filled. All the levels are completely filled. Except the last level. And in the last level, nodes should be as left as possible. So you should be filling those nodes from left to right. Okay, now take this example. Okay, now this is the first level, 0th level. First level, all are full. So here it is full. So what is this? This is a complete binary tree. If I can add here 2 more nodes, then this is again a binary tree. But if I add here one more node, this is not a binary tree. Why? Because here it is not completely filled. All the levels are filled here. Okay, all the levels except this is the last level. So all the levels are filled. This is correct, first condition. What about the second condition? The last level should be as left as possible. This is at left. No, this is wrong. So what you can do? We can, if you want, you can a node. You have to fill here this side. Okay, you have to fill this side here. Then this is a complete binary tree. So second one is complete binary tree. all the nodes are completely filled except the last level, and the last level nodes should be as left as possible. So this becomes a complete binary tree. So the first one, now here you can see one condition here. Okay, suppose if there are no trees, single node, still it's a complete binary tree. Whereas the first one, full binary tree, we needed either 0 or 2 nodes. Here we have only one node, one child here, only one child, but still it's a complete binary tree. The condition is only this one. All levels should be full, and the last level should have nodes as left as possible. So this is left hand side. So this is a complete binary tree. Still it is having only single child. The third one, so you have seen what is full binary tree, complete binary tree. The third one is perfect binary tree. Perfect binary tree. Perfect binary tree. Now, what are the conditions here? In perfect binary tree, all internal nodes have two children. All internal nodes should have two children. Should have two children. And what is the second condition? Second condition is all leaves are at the same level. All leaves or leaf nodes. All leaves are at the same level. Okay, all leaves are the same level. If for perfect binary tree is also, it can also be a full binary tree and as well as complete binary tree. Suppose if I draw here, take this. What is the first condition? What is the first condition? The first condition is all internal nodes have should have two children. So here internal node is only this one. Okay, two children. So this is an example of perfect binary tree. Suppose if I draw one more here, two children, two children, two children, two children. Is this a perfect binary tree? Yes. This is a internal. This is first condition. Internal nodes should have two children. This is internal node. This is the internal node. So two children. This is not internal node. It's a leaf node. Okay, it's a leaf node, and these are leaf nodes. Leaves node. So what is the second condition? The second condition is all leaves are at the same level. But here this is level 0, level 1 and level 2. So this is and this is here. The levels of leaves are different. So this is not a perfect binary tree. So to make this perfect binary tree, what you should do? You should you can take nodes like this. Okay, then this also should have nodes. So this is a perfect binary tree. A perfect binary tree is also a perfect binary tree. Perfect binary tree is also full binary tree, and it's a complete binary tree. Okay. So most of the basics we have cleared. Okay. Again, what I will do, I will upload some PPTs, PDF files, PPTs. You have to refer those PPTs. Okay. Now what we'll do, we will try to represent this binary tree in a computer. How we are going to represent this in binary tree in the computer? Suppose take this example. Now I have some nodes. Okay. Take a simple 1, 2, 3, 4, 5. So binary tree tree representing in a computer. Say binary tree representation. Binary tree representation. Now, how you are going to represent this in a computer? We know that binary tree is having maximum 2 children. That is so this is a binary tree because one is having 2 children, root node. Then other nodes 2 is having only 1 child, left child, 3 is having the right child. Okay. Now, how we are going to represent this in a computer? So, what data structure we can use? Now, to represent this, I can use like in linked list we have used single linked list. So I can use here double linked list. Okay, or a data structure, or I can use a data structure like say I can use a data structure where I will represent information. Now here information is what? This is integer. It can be a, then it is char. So information can be anything. So it will have, in our case it is integer, int I'll say info or data. Okay, int information. Then what I will have? I will have link. I will have connection, maximum 2 connections. So 2 connections to where? To these nodes. Okay, so to these nodes, so I can name it as a node. Name it as a node, and I can say it as struct node int information, or we can call data, or we can give any name to it. Then the next thing I need is a pointer to the left node and pointer to the right node. So what type of pointer they are? Struct node pointer left, struct node pointer right. So with this node, I can represent this binary tree. So how it is possible? Suppose the first node will have one. First node will have information 1. First node will have this information 1, and its left node will have a connection to one more node where its information is what? 2, and right node will have one more node which is 3. So this is right, left. Okay. Now suppose the root's address is say 100, and here its address is 200. This particular nodes, then it is 200 will be stored here. This address 200, and suppose this is 300. The address of this node is 300 in memory. So 300 is stored at this particular point. Now 2 we have only left node. So 2 is having only left node, which is represented like this 4, and there is no right node. So this is empty. Okay. What about node 3? Node 3 is having right node, which is the value is 5. Okay. So we have how many nodes? 1, 2, 3, 4, 5. So 4, 5 nodes are there. Okay, fine. So we have a link to this node. Right node is blank. What about the leaf nodes? Leaf nodes are having no connections to the next value. So here it is. So here it is null. Okay, null you can represent as 0 or X mark here. So null. Again, this is null here. It's not connecting anywhere. So 3 is connected here. This is correct. Now here it is null. And the address of this particular node is put here. Address of this particular node 200 is put here. They are addressed to links. Understood? How we can represent? The only thing is in computer terms, you have to represent this properly. Okay. Now let me write a program for this. This is for creating a link, creating a tree. It is creating a binary tree. Okay, not so what's the time? Time is 10 past 5. So I will take this program which is creating tree in C. Then later what we'll do in the next lecture we will see the traversal. Okay. So how we can write this one? So I will take this example, say tree implementation. Okay. Now I will take a simple tree here. The same thing. 1, 2, 3, 4, 5. Later you can trace this particular program. So to store this information, what I need? So this all is a code. This code you need all this code. Okay. Struct. We need structure to store this information. Structure int data, or you can give a name it as a what name as info data whatever. Then we have two pointers, struct node pointer, struct node pointer left and right. So this is a structure we need in this particular program. Okay. Then in main, what we will do in main? Okay. So this is structure. Can I rub this one? Okay. So we will. What I will do? We know how it is done pictorially. So I don't need to do this. So I will take from here. Struct node int data struct node pointer left and right, left pointer right.